Hello everyone, hope everyone is fine. So we are discussing our chapter which is dual nature of radiation and matter. So basically I will write here dual nature. So the topic that we are discussing here is dual nature, okay? Dual nature, and here we are discussing about one special effect which is known as your photoelectric effect. So photoelectric effect में क्या होता है? Photoelectric effect considers that light is consisting of particle and these particles are known as your photon, okay? So photoelectric effect means what? Photoelectric effect is basically based on consisting of light is, इसका जो idea होता है वो idea क्या होता है कि light consists of particle and each particle is known as photon and energy of each photon is E equal to h nu, okay? And from photoelectric effect we got one important relation which is known as your Einstein's equation. तो Einstein's equation क्या था कि h nu is equal to phi naught प्लस के ई. लास्ट क्लास में हम लोगों ने डिराइव किया था. तो फ्रॉम हियर वी गॉट दिस वन इम्पॉर्टेंट रिलेशन. देखो मैं फिर से तुम लोगों को यहाँ पे ओवरऑल जो फार्मूला है वो फार्मूला में लिखता हूँ. ओवरऑल फार्मूला क्या था देखो, दैट काइनेटिक एनर्जी विच इज इक्वल टू हाफ ऑफ, वी आर टॉकिंग अबाउट मैक्सिमम काइनेटिक एनर्जी, सो हाफ ऑफ एम वी स्क्वायर मैक्स इज इक्वल टू ई वी नॉट is equal to h nu minus phi naught, so is equal to h nu minus nu naught is equal to h c 1 by lambda minus 1 by lambda naught. So nu naught is known as threshold frequency. So what is nu naught here? Nu naught is known as your threshold frequency. ये किसका equation था? This is the equation for which the scientist Einstein got the Nobel Award. So this is Einstein's equation of photoelectric effect. So what is nu naught? Nu naught is known as the threshold frequency. That is, it is the frequency or it is the minimum frequency of a photon due to which it can eject an electron from the metal surface. So if your photon has a frequency less than threshold frequency, then it will not be able to eject an electron from the metal surface, okay? From here we will get some laws of photoelectric effect, very very important for your exam, which is known as laws of photoelectric effect. So what are the laws of photoelectric effect? देखो, first one, you guys already know that kinetic energy can never have negative value. So if your incident photon has a frequency less than threshold frequency, then your kinetic energy will be negative, which is not possible. So if your incident photon has a frequency less than threshold frequency, then it is not possible means what? It will not be able to eject an electron from the metal surface. This is the first law of photoelectric effect. So I will directly give you the laws of photoelectric effect as a note. So just give me 1 minute, not 1 minute, 1 second देने से भी होगा. 1 second तो हो गया. अच्छा, तो let us first discuss about laws of photoelectric effect. तो लास्ट क्लास में मैंने तुम लोगों को बोला था कि यहाँ पे 3 चीज़ है on which the photoelectric current depends. One is intensity, next one is frequency and third one is potential. Hope सबको मालूम है. तो laws of photoelectric effect में हम लोग क्या लिखेंगे देखो. The first law, हाँ मैं डायरेक्टली फ्रॉम नोट तुम लोगों को दे रहा हूँ. क्यों? क्योंकि ये एग्ज़ाम में आता है तो शॉर्टकट लिखने से नहीं होगा. तो हम लोग क्या लिखेंगे देखो, फॉर ए गिवन मेटल सरफेस, फॉर ए given metal surface these are the laws of photoelectric effect. So for a given metal surface and frequency of the incident radiation and frequency of the incident radiation comma the number of photoelectrons ejected per second, the number of photoelectrons ejected per second by the metal surface the number of photoelectrons ejected per second by the metal surface is directly proportional so number of photoelectrons किसका ऊपर में डिपेंड करता है? That is directly proportional to the intensity of incident radiation, क्योंकि जितना ज़्यादा लाइट का इंटेंसिटी होगा उतना ही वहाँ पे नंबर ऑफ फोटॉन्स ज़्यादा होगा, जितना नंबर ऑफ फोटॉन्स ज़्यादा आएगा उतना ज़्यादा फोटो इलेक्ट्रॉन्स इजेक्ट होगा। ये मैंने बोला था वेरिएशन ऑफ इंटेंसिटी में, ठीक है। इज डायरेक्टली प्रोपोर्शनल टू द इंटेंसिटी of the incident light, intensity of the incident light, okay, so this is the first law, okay। ये इसके बारे में ऑलरेडी हम लोगों ने डिस्कस किया था। अच्छा, नंबर टू क्या होगा? देखो, सेकेंड वन आई विल राइट हियर। Second one is this one. Second one यहाँ पे लिखता हूँ अभी कि फॉर ए गिवन मेटल सरफेस, इस बार हम लोग थ्रेशोल्ड फ्रीक्वेंसी के बारे में डिस्कस करेंगे। दैट फॉर ए गिवन मेटल सरफेस कॉमा देयर एग्जिस्ट ए minimum frequency of incident radiation, there exists a minimum frequency of incident radiation, और इंसिडेंट लाइट का अगर फ्रीक्वेंसी उस फ्रीक्वेंसी से कम हो गया, मिनिमम फ्रीक्वेंसी से, देन फोटो इलेक्ट्रॉन्स विल नॉट बी इजेक्टेड। देयर एग्जिस्ट ए मिनिमम फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन below which no emission of electron will take place, okay। This frequency is called threshold frequency. This frequency is called threshold frequency. This frequency is known as what? This is known as threshold frequency। मतलब इंसिडेंट वेव जो है, इंसिडेंट जो लाइट है, उसका फ्रीक्वेंसी मस्ट बी ग्रेटर देन थ्रेशोल्ड फ्रीक्वेंसी इन ऑर्डर टू ऑब्टेन फोटो करंट, ओके। तो दिस इज द सेकेंड वन। सो व्हाट इज द थर्ड वन? थर्ड वन क्या होगा? देखो, अबव द थ्रेशोल्ड फ्रीक्वेंसी व्हाट विल हैपन? इफ यू इंक्रीज द फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन, then what will happen? Stopping potential will also increase due to the increase in kinetic energy। सब चीज़ें हम लोगों ने ऑलरेडी डिस्कस कर चुका है, तो जिसका पास नहीं है, जिसने वो वीडियो देखा नहीं है, उसने एक बार फिर से देख लो, मतलब उसने एक बार सही ढंग से देख लो, और जिसको डाउट है उसने वो वीडियो फिर से देख सकता है, ठीक है। यू कैन ऑल्सो डाउनलोड द वीडियो, यू हैव गॉट स्क्रीन रिकॉर्डर ऑप्शन ना। ऐसा कोई बात नहीं है कि मतलब बाद में तुम लोगों के पास वीडियोस नहीं रहेगा, तो यू गो विथ स्क्रीन रिकॉर्डर, ओके। Number three is above the threshold frequency. Above the threshold frequency, तो इस बार हम लोग किसके बारे में डिस्कस कर रहे हैं? स्टॉपिंग पोटेंशियल। तो above the threshold frequency, comma, the maximum kinetic energy of photoelectron, the maximum kinetic energy of the ejected electrons. The maximum kinetic energy of the ejected photoelectron is independent of, वो इंटेंसिटी के ऊपर में डिपेंड नहीं करता है ना, so is independent of intensity, because intensity what? Intensity, more intensity means more number of photon. So kinetic energy does not depend on intensity, is independent of intensity of incident radiation and depends on the, but it depends on the फ्रीक्वेंसी. ओके, तो ये किसका ऊपर में डिपेंड करता है? फ्रीक्वेंसी, क्योंकि फ्रीक्वेंसी बढ़ेगा तो जो इंसिडेंट फोटोन है उसका एनर्जी भी बढ़ेगा. अगर ज़्यादा एनर्जी है उस फोटोन का तो इजेक्टेड फोटो इलेक्ट्रॉन्स का भी ज़्यादा एनर्जी रहेगा. ठीक है, is a but depends on the frequency of the photons of incident radiation. ओके, अच्छा नंबर फोर क्या है? देखो, नंबर 4 इज the photoelectric effect is an instantaneous phenomenon. So what do you mean by instantaneous phenomenon? देखो, जब मैंने फोटोइलेक्ट्रिक इफेक्ट का एक डायग्राम ड्रॉ किया था ना, तो उस डायग्राम में जब भी हम लोग अलाउ करेंगे तो द लाइट टू फॉल ऑन द सरफेस, if the incident light has a frequency greater than threshold frequency, then immediately वहाँ पे जो एमीटर हम लोगों ने कनेक्ट किया था, the emitter will show you some recording or it will deflect from its original position. इसका मतलब when we will allow light of suitable frequency to fall on a metal surface, then immediately the photoelectric current will start to flow. So the next one is photoelectric effect is an instantaneous phenomenon. So next one is the photoelectric effect is an instantaneous phenomenon. मतलब ये immediately शुरू हो जाता है. ठीक है, the time lag between the photon striking the metal surface, the time lag between the photon striking the metal surface an emission of photoelectron and emission of photoelectron is 10 to the power minus 9 सेकेंड. देखो ये कितना कम है, 1 नैनोसेकेंड. मतलब when the photon will strike the metal surface, then electron will be ejected ना. तो what is the time lag? मतलब strike करने के बाद within मतलब after 10 to the power minus second, the photoelectrons will start to flow. So it is an instantaneous phenomenon. So these are the 4 laws of photoelectric effect which is very very important for your exam. Okay, इसीलिए तो मैंने वहाँ पे तुम लोगों को लिख के दिया है, अदरवाइज तो मैं नहीं देता. डन. ओके, सो आफ्टर दिस आई विल शो यू सम ग्राफ. नाउ ग्राफिकल डिटर्मिनेशन ऑफ प्लैंक्स कांस्टेंट. प्लैंक्स कांस्टेंट क्या था? h. नाउ द क्वेश्चन इज हाउ वी कैन डिटरमाइन द प्लैंक्स कांस्टेंट विद द हेल्प ऑफ ग्राफ. So we can easily determine because from the Einstein's equation. Okay, and you already know one thing, that what is the equation of a straight line? Y equal to mx plus c. ये तो याद है ना तुम लोगों को, where m is the gradient or slope of the graph and c is the intercept. ठीक है, चलो. ओके, मैं एक चीज़ तुम लोगों को फिर से बोलता हूँ यहाँ पे. देखो, ये यहाँ पे मान लो ऐसा एक ग्राफ था, तो व्हाट इज द इंटरसेप्ट हियर? दिस वन इज सपोज y एक्सिस, दिस वन इज सपोज x एक्सिस. देन व्हाट इज द स्लोप हियर? स्लोप इक्वल टू थीटा So m, this is the gradient, is equal to tan theta. You already know what is this portion. This portion is equal to your c. c मतलब intercept. ये जो portion है यहाँ पे from here to here, this portion is known as your c. c मतलब intercept on y-axis. Done. This is the origin here. And what is the equation of this straight line? Y equal to mx plus c. Done. Now, what is the Einstein's equation? So now graphical determination. ये भी important question है for your board. ठीक है, कभी कभी 1 mark का सवाल आता है कि how will you determine the Planck's constant graphically? So graphical determination of Planck's constant. Okay, graphical determination of Planck's constant. So we have number 1 पे देखो, we have what we have from Einstein's equation. क्या मिला था कि EV naught is equal to h nu minus phi naught. You got this formula from Einstein's equation. EV naught is equal to h nu minus phi naught. Okay. Now from here we can say that divide both sides of the equation by e. So it will be h by e into nu minus phi naught divided by e. So from here we can write that v naught equal to h by e. H is Planck's constant, it's a constant, divided by E, charge of an electron, another constant, minus, इसको हम लोग ऐसे लिखते हैं कि this is plus minus of phi naught divided by E. So this is what? You know that with increase in frequency, the stopping potential also increases. So this is the independent variable here. So this one is equal to y, this is the constant, so m, this is x, this is plus. What is this? This intercept is here equal to what? Minus of phi naught by e. मतलब negative intercept होगा यहाँ पे. The intercept will be negative here. So what will be the graph? Graph देखो. Independent variable यहाँ पे कौन सा है? Independent is frequency of the photon. Done. And this side is stopping potential. In this side we have got stopping potential, which is represented by V naught. Stopping potential is represented by V naught. अच्छा, then what will be the graph? देखो ग्राफ में एक इंटरसेप्ट है ना, इंटरसेप्ट कौन सा है? नेगेटिव इंटरसेप्ट है, तो ग्राफ विल स्टार्ट फ्रॉम दिस पोजीशन. सो व्हाट इज दिस फ्रीक्वेंसी? इट विल बी ए स्ट्रेट लाइन. हाँ, सो ये जो फ्रीक्वेंसी है, दिस फ्रीक्वेंसी इज नोन एज न्यू नॉट. न्यू नॉट मतलब थ्रेशोल्ड फ्रीक्वेंसी, एंड दिस वैल्यू, दिस इज नोन एज योर this portion is minus of phi naught by e. So this is the theta. So here what will be the value of tan theta? Tan theta is nothing but m, and m is nothing but here h by e. So m is equal to tan theta, and tan theta is nothing but h by e. So if you know the angle which is equal to your theta, and you know the charge of an electron, that is 1.6 into 10 to the power minus 19, so you can calculate the value of h from this graph. Okay, so this is one example or one graphic way through which we can determine the Planck's constant graphically. Okay, because you know charge of an electron, and if you know this angle with the help of some device, then you can easily calculate the Planck's constant. But one more equation is there to calculate Planck's constant. और एक उपाय है, वो उपाय के बारे में भी हम लोग अभी डिस्कस करेंगे. ओके, तो उसका जो दूसरा उपाय है, जो अनदर वे टू डिटरमाइन द प्लैंक्स कांस्टेंट ग्राफिकली, उसको हम लोग देखते हैं अभी. ठीक है. अच्छा, अभी देखो ये जो इक्वेशन था, ये इक्वेशन, इन दिस इक्वेशन व्हाट इज ईवी नॉट? इंस्टेड ऑफ ईवी नॉट वी कैन राइट काइनेटिक एनर्जी ऑल्सो. सो दिस इज द पार्ट 1 और फर्स्ट way to calculate the first method to calculate the Planck's constant graphically. Second one is kinetic energy is h nu minus phi naught. Okay, so you already know that if you increase the frequency of the incident photon, then kinetic energy of the photoelectron will also increase. So this is independent variable. This is dependent variable. Okay, so we will consider this equation as in this way, that kinetic energy is equal to h nu plus minus of phi naught. यहाँ पे भी इंटरसेप्ट क्या होगा, नेगेटिव. सो दिस इज अ वेरिएबल ना काइनेटिक एनर्जी, सो इट विल बी कॉल्ड एज वाई. वाई बिकॉज दिस वन इज अ डिपेंडेंट वेरिएबल. ओके, अच्छा, h इज ए कांस्टेंट, सो इट विल बी सपोज से m. frequency is another variable, plus minus c. So what is the slope of the graph? If we draw here a straight line, this is an equation of straight line, na? This is nothing but equation of straight line. Similarly here also, this is nothing but equation of straight line, क्योंकि वो match कर रहा है ना with the equation of straight line. तो what we will write here, लिखने के लिए तो कोई बाकी है नहीं, यहाँ पे ड्रॉ करते हैं. ये एक्सिस में क्या रहेगा, डिपेंडेंट वेरिएबल विच इज काइनेटिक एनर्जी, एंड इन दिस एक्सिस वी विल बी हैविंग द इंडिपेंडेंट वेरिएबल विच इज फ्रीक्वेंसी. इंटरसेप्ट इज नेगेटिव ना, सो द ग्राफ विल लुक लाइक दिस. This portion will be minus of phi naught, this portion. This is threshold frequency. ये देखो, when your applied frequency is less than threshold frequency, क्या कुछ kinetic energy था? No. So what we said? We said that when your incident frequency is less than threshold frequency, no photoelectrons will be emitted. अगर photoelectrons ही emit नहीं हो रहा है तो kinetic energy कहाँ से मिलेगा? देखो, ये जीरो है, so from here to here your incident frequency is less than threshold frequency, so no more kinetic energy here. So this is threshold frequency, this is the slope of the graph. Slope of the graph is theta, so m is equal to, from here we know tan theta, and this is nothing but h. So if you know the slope of kinetic energy versus frequency graph, this is nothing but Planck's constant. So finally what we can calculate, what we can conclude from this one, আমি ইয়াৰ পৰা কি কনক্লুড কৰিব পাৰোঁ চোৱা, যে tan theta means what? Tan theta means slope. So slope of kinetic energy and frequency graph, slope of kinetic energy versus frequency graph will give us the value of Planck's constant, which is here equal to h. Okay, so how we can determine the Planck's constant graphically? One is this method, that is from this equation. ये था यहाँ पे master equation, that is ev naught equal to h nu minus phi naught, and in the second one directly from kinetic energy. So here मैं फिर से बोल रहा हूँ, if you already know, यहाँ पे कोई if का ज़रूरत है नहीं, you know the charge of an electron. So if you know the slope of this curve, slope of किसका curve, slope of stopping potential versus frequency, then you multiply that slope with charge of an electron, you will get Planck's constant. Otherwise, directly from kinetic energy and frequency curve, you take the slope, and that slope will give you the value of Planck's constant. So what is the value of Planck's constant? You know already, this is 6.626 into 10 to the power minus 34 joule into second. Okay, so till now we are saying that means in photoelectric effect we are saying that the light is consisting of particle, and which is known as your photon. So we already know one thing also, that light is nothing but wave also. So photoelectric effect is a phenomenon that can be explained by considering light as a particle. Okay, so when we started wave optics, then I said that some phenomena can be described by using light as a ray of, by considering light as a particle, and some phenomena can be described by considering light as a wave. For example, wave में कौन कौन phenomenon था? Interference, diffraction and polarization. Whereas by considering light as a particle, we have to explain photoelectric effect, and we can explain Compton effect, etc. Okay, and by considering light as a particle and as a wave also, we can explain both the basic properties of light, that is known as reflection and refraction. So reflection and refraction are the two phenomena that can be that can be explained by considering light as both wave as well as particle. Okay, so with this we have to I will finish this class. In our next class we will begin with where the wave theory fails. The photoelectric effect can be explained by considering light as a particle only. तो wave theory जो था वो photoelectric effect में कहाँ fail हो गया, ठीक है? That we will discuss in our next class. Done?